I have a standard ferrite ring magnet. This ferrite core enhances the magnetic properties of our antenna project. I will use a screwdriver to carefully inspect the ferrite core. Next, I'm taking a long piece of blue insulated copper wire. I'll pass it through the center of the ring and begin wrapping it tightly around the magnet. I'm using hot glue to secure the wire ends to the ferrite core. We are creating a toroidal coil, which is excellent for picking up electromagnetic signals. I'll make several neat turns all the way around to ensure we get a strong induction field. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Once the coil is finished, I'm securing the wire in place with some hot glue so it doesn't unravel. Then, I'll strip the insulation off both ends of the blue wire. I'll use my soldering iron to tin the exposed copper tips. Tinning them now makes it much easier to solder them securely to a circuit board later on. Let's grab an old and used Wi-Fi router. I'll open up the plastic casing to access the main circuit board inside. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm going to solder the two tinned ends of our blue wire coil directly onto the router's antenna connection points. This will allow our new coil to utilize the router's internal circuitry to process and boost the signal. I need a way to connect this to our TV's input. I'm taking a standard 2-prong power plug with a short length of wire attached. I'll pass the wire through a gap in the router's case. I'm using a soldering iron to solder it to the connection points on the circuit board. After that, I'll carefully reassemble the router's casing, making sure all wires are neatly tucked inside so it looks tidy. I'm applying a generous amount of hot glue to the top of the router and firmly pressing our wire-wrapped magnet onto it. This keeps our entire antenna assembly compact and secure. For the next part, I'm taking a standard surface mount power socket and unscrewing it to open it up. I'll strip a section of a black coaxial cable, separating the inner solid core from the outer braided shield. I'll then attach these two parts of the coaxial cable to the internal screw terminals of the power socket. This might seem strange, but we are using the socket housing as a sturdy connector block to interface with the plug we added to the router. Let's put the socket back together. On the other end of that black coaxial cable, I need to attach a standard TV antenna connector. I'll strip the wire carefully, fold back the shielding, and screw on the metal F connector, followed by a right angle adapter. This is crucial because it will plug directly into the back of our television. As you can see, my TV currently says, "No signal." Now, I'll take the power plug from our modified router unit and plug it directly into the special power socket we just wired up with the coaxial cable. Look at that! The TV is instantly picking up dozens of channels with crystal clear picture quality, all for free. This homemade antenna works perfectly. Let's grab the remote and see what happens. I can flip through all the local broadcast channels flawlessly, without any buffering or artifacts. Just to prove it's not magic, let me unplug the antenna from the back of the TV. See, instantly, no signal appears again. This confirms that our DIY device is indeed responsible for pulling in those channels. Now, let's plug it back in. And just like that, the signal returns, and we have live TV once more. It's consistently working across various channels. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what you think. Don't forget to subscribe to the channel for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next video.